All right, electric field lines and diagrams. This is section number 8. Pretty quick too because it's mostly diagrams, okay? Take a look at this, right? There's a lot of diagrams here so that you can kind of we can kind of illustrate it to you, right? If you look, field lines, so these are the way that field lines orient themselves when there are two opposite charges. They connect, okay? So when you have the lines, they always come out of positive charges and go into negative charges, okay? When the electric field lines leave the positive charge and they see a negative charge, they want to go towards it, right? So they form this melon shape. It looks kind of like a watermelon, right? And you see, right, you get this, you show that there is electric field between the two, okay? However, if you have two like sign charges, they repel, okay? The electric field lines repel each other, and they form this diamond shape. If you may recognize it, it looks more like a primo gem, kind of, right? If you've ever played some kind of video game, I don't remember which one, okay? But look at that, right? It looks like a primo gem, right? I already want to get my wallet out and pay for it, okay? So there's kind of makes like a diamond shape, and you should notice that in the center, okay, there is no electric field, okay, because it cancels out for each other, okay? Here, another thing to note is that electric field lines always intersect conductors perpendicular to the surface, so you notice that the electric field lines are reorienting themselves so that they can intersect perpendicular with the conducting wall, okay? You'll notice that these charges have opposite sign, and in both of the diagrams, the left charge is stronger than the right, okay? And you can tell the strength of a charge because the more arrows or the more field lines, the stronger the charge. So more lines, stronger charge. Okay? Here, again, same thing. More lines equals stronger charge, right? Less lines equals weaker charge, okay? So here again, these two, so you'll notice another thing too, is that in these two diagrams right here on the right, where the left charge is stronger than the right, you'll notice that the point where those charges are, where there's a 0 E field, is actually a little bit closer to the weaker charge, right? And that should make sense because the stronger charge is going to bleed more into the right, into the weaker charges area, right? So you can see that where the charge is equal to 0 is a little bit more offset towards the second charge now if the first charge is stronger, right? So the stronger charge actually pushes that 0 point towards the weaker charge, okay? Okay, we've got 3 charges that make this electric field pattern shown. We have some of these little bubbles for letters, right? And you're thinking like, oh, I got to select the correct answer on the test. No, that's not what we're looking at right now, okay? We can identify the sign of each of the charges based on how the electric field lines orient themselves. If it comes out of the charge, if the arrows are pointing away from the charge, then it's a positive charge. If it goes into the charge or the arrows are pointing towards it, it's a negative charge, okay? So charge 1 would have to be positive, okay? Charge 2 is also positive because the arrows are pointing away from it. Charge 3 is negative, okay? Lines always, the E field lines always leave positive charges and enter negative charges, okay? Draw vectors at each point to represent the direction of the E field at each of those points. Okay, so let's use, let me use purple right here, okay? The E field is always going to be tangent to the lines, okay? Because these are electric field lines, but if we're talking specifically at that point, the vector is going to be tangent to the line. So, for example, for D, it's going to be tangent to the line right here, okay? That's ED, okay? E, it's going to be tangent to the line, okay? E, okay? Dolphin moment, right? Okay. A is going to look kind of like this, okay? EA, sports, it's in the game, right? Okay. C is going to go directly to the left. That's EC. I don't have a joke for this one, okay? B is, again, tangent to the line that way. EB, okay? There's like an old video game store called EB, okay? We need to figure out where the electric field is 0. So do you see any diamonds in here, any primo gems that formed? Oh, look, there's one right here, okay? There's one that forms right here, okay? There you go. That's where it is, okay? Okay, So look for the center of a diamond, right, to figure out where the electric field's 0. Which charge has the greatest magnitude? Well, you just got to see which one has the most lines either going into it or out of it. And if you count those up, it'll actually end up being charge number 1, okay? And the least magnitude would be charge number 2, okay? Most lines and least lines, okay? At which lettered point is the field the strongest? We're looking for highest density of lines. Okay? We're looking for the highest density of lines. So which point has the highest density of lines? It's about point B. Okay, notice that B, we've got a ton of lines near it. Okay, none of the other points have that many lines near it. If we placed a proton, this is important, it's asking us a proton, okay, where would it go if it was placed at E? Well, remember, protons follow the E field, okay? So if it goes to E, it's going to go down, okay? If we place an electron at point D, it opposes the E field, okay? So it would go down as well, okay? Okay. And then right here, right, I'm not going to redraw everything here. I'll just show you what I have in my key for this because it's a lot of drawing and I don't want to waste your time with showing you, with like me drawing everything out for you. But here's what the E field lines would look like, right? So shaded regions are conductors, clear regions are insulators. Notice in the left one, right, you get the melon shape and then, there are lines outside of the melon shape as well. Here you get the melon shape between the like charges and you'll notice that between the unlike charges and diagonally, there is a diamond shape as well, okay? You get melon charges between the unlike charges and then the like ones have that diamond shape in the middle, okay? Here, notice that in the bottom lines, they are reorienting themselves so they intersect perpendicular with the conductor. However, with the insulators, okay, it doesn't matter. The electric field lines will just go through the insulators, no problem. They're not going to reorient themselves. And then finally, when you're in here, you have a charge inside of a conductor. You'll notice, again, they're reorienting themselves so that they intersect perpendicular with the conductor. Okay, it looks weird, but that's just kind of what it looks like, right? It would intersect, and there's more lines, of course, right? There might be more lines. They would all reorient themselves to intersect perpendicular with the conductor, okay? All right, that's it. Nothing too crazy about it. All right, have fun.